All right then, let's get started. Cool, thank you for joining, especially when Martin is speaking on the other stage in parallel. It's cool that so many people joined the sessions. I'm going to talk about gRPC APIs that we built for autonomous driving, and we're going to go from design to implementation in Scala, obviously. I'm Bendix, I'm a staff software engineer working for Moya. I used to be a Scala developer and now mostly do some software architecture stuff, cross-team projects, lots of stakeholder management, that kind of things that need to be done as tech leads. With Moya, we've been doing ride pooling, so that's pooling multiple trips of like private car trips or taxi trips into one vehicle because it's more sustainable. And we have hundreds of vehicles in Hamburg and doing that since 2019. And at the moment, we're currently working on integrating autonomous driving into cities. And all of that backed by Volkswagen. And in this talk, I'm going to show you how we build our core APIs that we have public facing with some examples in Scala, obviously. There's not much of Scala code that you get to see here because this talk more shows how we use Scala in the wild. Let's start with a bit of motivation why we did the whole thing. And we have autonomous vehicles here. And we want to make them a tool for public transport. We've vehicles from different car makers, so VW and Holon and others. And we think they need an ecosystem to work. And we're building that ecosystem. And to do that mobility as a service ecosystem, we need to take over all tasks previously performed by drivers, like on the side, especially taxi drivers. So they do that boarding authentication. Hey, is it you, Peter? Like, you need to check that somehow when there's no driver. And incident handling, what happens if the person feels sick or the car has an accident? Someone needs to do that if there's no driver, and previously drivers did that. So we need to automate all of that. And then there's the whole fleet control thing, that if you don't have one vehicle, but tens or hundreds or even thousands, you need to manage that fleet, and that's repairs, that's charging, that's taking over in case the self-driving system doesn't know how to drive because there's some odd situation, and that happens with all autonomous vehicles. So we have to take care of that, and we're building that fleet control system. And another layer on top of that is our third-party connector. Because I said we want to make autonomous vehicles a tool for public transport, we need to integrate with public transport, or they need to integrate with us. And for that, they need an API. And we've all built APIs over the years. And we wanted to do that in a domain-driven design way and start fresh with it. And so we built new APIs over the past 1.5 years. We had some APIs in the past. Of course, we have many internal APIs, but we wanted to have these public APIs and incorporate all the functionality for autonomous driving. And we partner with public transport operators. So in Hamburg, it's the Hamburg Hochbahn. And they have their app, which you can use to order autonomous trips, and you can also use our own app that we have. And both use that API that I'm going to talk about. So we do have, as I said, multiple pilot projects with autonomous vehicles. We have in Hamburg, we're starting a closed user group service where actually anyone can order an autonomous vehicle. Next quarter, we have service running in Austin, also we're testing things. We have a test track near the airport in Munich, which is kind of nice to test like these incident scenarios. What happens if a bike suddenly comes onto the driving lane? We did some winter testing. Oh, let me go with the slides. We did some winter testing in Oslo because it's interesting to test snow. Every other autonomous vehicle company that you know, they test somewhere in southern US. There's sunshine all the time. That's kind of easy, but snow is kind of hard to get right. So we did some winter testing in Oslo. And next year we're going to start in Berlin testing together with the BVG. And we're also integrating one of the other public API that we built the same fashion with Uber for LA. So we did that using protobuf and gRPC. So maybe quick show of hands, who have used protobuf? Okay, that's almost everyone. Who knows gRPC? It's always nice. I'm going to introduce it anyways. But I'm going to do it quick. So there's a schema definition, protobuf, short for protocol buffers. It's a typed language. We have nice serialization, very efficient and compact. we have code generation, we have the very awesome Scala PB library that you can use as an SPT plugin, for example, and then it generates Scala bindings and also all flavors like Akka, Pecco, Zio, Futures, whatever you want to use. That's very neat, and it has like this optionality built in, and you can define messages, and that's very nice to use. It even supports enums, like Scala 3 finally does, and you can even implement recursive types if you want. That's kind of fun in Proto. So much for Proto. Let's take a look at gRPC. So this is a traditional, I'd say, REST HTTP 1.1 call. You have that post to some endpoint, and then you have a body. Let's assume the body is maybe some Proto message. So this is order trip request that we call. Then you send one request, you get one response, and then you do another request and another response. So that's pretty easy to imagine because we've all seen that in the wild. gRPC is a bit different. You have unary RPCs and you have streaming RPCs. If we take a look at the unary RPC, we have the order trip. This is the method now. It's not post something, it's order trip with the order trip request in the body, and you get the order trip response. I think it's kind of speaking as an API of what to expect. And for streaming, you just have multiple messages because we have long-lived connections here between client and server. For gRPC, services are also defined in protobuf. You have that service keyword, and that signals there's a service, and then you have RPCs for like basically the RPCs, like the remote procedure calls. They're from the 60s, I read, and the term was coined in 1981, so like long time before I was even born. So it's a fairly old tag. And then in 2015, Google open sourced their internal implementation based on HTTP2, and this is then how it looks. And we have these protobuf definitions and many services that backing, like many different services, and then the backend services behind that are written in multiple languages, like Kotlin, Go, but also many Scala services, and that's why I'm talking here. And what language teams want to use is based on their choice, and if we compare that to Scala code, just replace RPC with def, and it almost looks like a Scala function or method definition, but probably you would want to have some effect type on the result, right? So like IO, future, Zio, whatnot. So let's take a look at this code. This is generated code using Scala PB and a very simple service. So we see here the def get trip. That's exactly what we had before. It takes a get trip request, and here returns an IO of either status exception or a get trip response. Fairly simple implementation, just using some in-memory storage for now, and returning successfully in this case. And it uses this Zio trip service that we get from Scala PB. And down below, we just bind the bindings that were generated, use netty for transport, start the server, and there we have it. So that's pretty straightforward, I think, and it's kind of neat that we get all of that, or like most of it, created based on that proto definition for us, and we don't have to do a lot of code generation or boilerplate stuff to do. And you can also generate bindings, as I said, for HTTP4S and others. We just happen to use Zio a lot at Moya. And this is a client example. So one was the server, and for a client, same similar thing. We have the same method definition, the similar method definition. We need to give an access token, custom ID, and offer token, and then we do get back some client error or a string as an IO. Here again, we have some gRPC service that does some auth kind of things, and then we also use that Zio trip service client, do some stuff, send the request, and here we go. It's also mostly auto-generated, and this code also was generated a lot with Cloud Code, so that helps if you have protobuf definitions, because AI can pick that up easily. Okay. That's about the technicalities as an introduction. Now let's take a look at how we did the API design, because I said we wanted to discuss API design. And I think an API is much more than just implementation. We just always try to say API first, go ahead, let's develop an API, and then see how it's going to be used. No, I think we have to do many multiple steps before to actually think what do we actually want to build. And over the past 1.5 years, I compiled this kind of long list of what I think are success criteria for an API. Please tell me if I forgot something that you come up with after the talk and then the Q&A, because I think many of these things you have to bake into the API design and you cannot retrofit, or maybe you can, but it's more work, and it's good to think about that up front. And maybe we can even talk about that. I don't know, maybe you want to have an MCP server, and maybe you want to ensure that AI can read your and understand your documentation, I don't know. But as I said, we've made quite good experience with gRPC and coding agents. So let's take a look how we started trying to check off the success criteria. So we are huge fans of domain-driven design because it helps to have that shared language between business people and developers. And we, as I said, knew what we are going to build. We knew the context because we have been doing ride pooling for many years, and we knew some stuff about autonomous driving already with some internal tests, and we just wanted to build a new API. So we sat together and designed that. And we used something from event storming, from domain-driven design, and we sat down and collected all entities and value objects that we have, or that we thought we need for the API. So nouns, basically. And then we added verbs to those nouns. Like a noun might be trip, and a verb might be order. I want to order a trip. So we can easily add that, just in a different color. And then we travel through the stickies to form stories, basically. And then we already have kind of how would one use the API in actual implementation. I'm going to show an example in a second. And then we identify root aggregates that we want to expose as one service on the API. And this is kind of useful for cutting API services that you can also then use to inform cutting microservices backing the API on a lower level, or you can even go more crazy and shape your teams based on that, following the team topologies. And then you have one team doing maybe trip stuff, call it trip management, and you have maybe one team doing prices, and they are called pricing, or something like that. I said I wanted to give an example. So in yellow, you see the nouns that we came up with. So this is a very contrived, short example. We have 3 nouns, customer, trip, and offer, and we added in green some verbs. And there are multiple ones, and now we can just basically travel through the stickies and to show some journey. For example, we do create a customer, then we request some offers, we order that trip, then we subscribe to trip updates, and hopefully we do not cancel a trip. And then I have that story, and I can do that multiple times from different perspectives, and I have quite some good understanding about how the API could be used in the wild. And I think if we now model that in gRPC, because the methods, or the RPCs, are actually called order trip, we have that ubiquitous language from domain-driven design where business people, product managers, I don't know, engineering managers, they have the same language, they use the same language. If we have the RPC order trip and I'm saying, I'm implementing order trip at the moment, they know what I'm talking about. And if I'm saying, yeah, I'm working on that post endpoint trip, something returning to 100, they are like, what are you doing? I don't have to translate. And I think that's kind of cool that we share the definitions and have them encoded in Proto and can auto-generate documentation based on that we can use throughout the company. So this is based on the previous thing that I've just shown, that you can use, you can do it manually on a board, but you can also use some online whiteboarding tool if you want to do it in hybrid or remote settings. This is the Proto or the gRPC service that we built based on that. And this is actually the core of our trip API, because it's the trip service. We want to order trips. And here you see that we decided trip as a root aggregate, so noun that we want to expose on the API. And we also said that offers are not a root aggregate in DDD terms, because we say an offer is so much like linked to a trip that we made it a sub-aggregate of the trip. So request trip offers is an RPC on the trip service. We don't have an offer service because they are not long-living. They just convert into a trip. And we have mutations on there, but we also have, we can have getters like getTrip and something. And there's even a streaming RPC of subscribe to trip events, and more to streaming a bit later. So why am I talking about root aggregates and how this domain-driven design thing? So this is a quote from John Osterhout of Philosophy of Software Design, and he talks about deep modules, and he says best modules are those that provide powerful functionality, yet have simple interfaces. And I think this is a simple interface, but you can do a lot with it. And that's kind of cool, because it looks very simple and it's understandable even by business people. And okay, now that we did our event storming initial phase, we have to design the actual, like, now we need to define what's a trip. And we need to decide on like the functionality of the stuff, and not only like what do we want to order, what do we want to mutate, and what do we want to get, but what's the actual content of that, so the messages. And we did that in collaborative workshops, and that means we focused on one small topic, for example, one RPC for a session, did that very short, 2 hours, because otherwise people won't listen anymore. And we did that in diverse rounds, because I said we wanted to have that ubiquitous language. We included product managers, we included, of course, the tech leads of the teams, even user experience designers, some subject matter experts. We still tried to keep the group small for having intense discussions, but also included the diverse perspectives of the people that would work with that. And we took like extensive protocols on the discussion points and also the decisions. And if there were some questions open, we just didn't like blow the timeline, but like had follow-up meetings to discuss that in depth. And don't have more than one workshop a day because people are too strained afterwards. And what helped us is we didn't think of this new API as a version 2.0, but like really started from scratch. And we had, of course, some definition of what's a trip, what's a stop or something, and we mostly changed them. There were many breaking changes for the teams internally, but it also helped because now for the first time, we had a definition that was coined together with business people and developers, and we shared that definition. And before we had like somehow definitions that like were diverse across the groups and even teams, because they just like evolved over time. In the end, that was mostly my job, is take all the decisions and compile a design document based on that, and just link to the discussion protocols to keep it short. And then I sent it to all the stakeholders, everyone, and asked them to comment. And if they didn't comment, I took that as an approval, and we started implementation. And then comes the interesting part. Now we have a design document. We know what we want to do. We've decided on that together, but now we have to do that. And the actual doing is, of course, teams can just write code, but writing code is good. We still have to make sure that all that we decided upon, and that's also like shared naming and stuff, we need to ensure that this also is kept during the implementation phase, and that at best the API feels as if it has been written by one person, and also documentation as if it has been written by one person, but obviously it wasn't. Like 40 people worked on that, so it's a bit of glue work and oversight to do that. So I think to make a good API, you have to do that governance. And I use a capital G here because I mean not writing about governance and not talking about it, but actually doing that. And that may be annoying to some developers if I came and say, can you please write more documentation here, and can you please change that here? Because basically I made myself code owner for all the protos, I made myself code owner for the documentation, and annoyed people the heck to follow the guidelines that we came up with together. And I think guidelines are important because we want to have that consistency across the API, as I said, and we want to have some uniformity. In gRPC, what's a bit hard is how to do error handling, because there are status codes, but you want to probably give more error details. And there's a standard by Google that they're using for error details, but you also still have, that's not auto-generated, unfortunately. You have to put a bit of effort in there and to discuss that with all the teams. And we wanted to have inclusive language in our API. So previously we had walking durations, and then we said now we have vehicles that support wheelchairs. Like walking duration might be a bit off, so we just renamed that to approach duration. Like thinking about that, also bringing in diverse perspectives from UX writers to make sure that we have a good API. And we want to have that clarity in writing here. And all of this, lint where possible. Like use every possible linter that could help you. There are good linters for protobuf, like buff. Use, I don't know, Copilot for catching typos in your documentation. Comment in the proto as much as you can, because it helps. And enforce where necessary, like by performing PR reviews. And then comes the interesting part. Whenever you get feedback from someone, or someone asks a question, did I get that right? Document it. Just like keep on documenting until there are no more questions asked. Even though it might be tedious. So in the end, we came up with a nice website that has, it's public, so you can open it later if you wish. And it has all the functionality described that we had here, and some of the stuff is auto-generated based on the protos and the comments, especially the API reference. And we want the teams that own the services and implement the services to write the documentation on their own. So again, we needed to have PR reviews for that consistency of some core maintainers, and we added some more stuff to that, like an intro, what's the API about. We had the API reference automatically generated from protobuf, which is kind of neat that you get that out of the box with proto. We have guides for like common tasks, like the story that I've shown you with the event storming. We just put that in a guide because that's what most probably integrators will want to do. We have explanations on some complicated topics, like for example the trip states. There are multiple states. How can they change? And we have a glossary and of course changelog and search, so something that everyone should have. And there's even some theory for how to write good documentation out there that I can definitely recommend, and that's this Diataxis framework. And they claim there are 4 needs for documentation. One is like learning how to use something, and then like to achieve a certain goal is one thing, then understanding something deeper, and just getting information. And that requires 4 different types of documentation. So for the learning part, we want to have an introduction, just like, what is this about? If you want to reach a certain goal, you definitely want to have that guide, because it guides you to reach that goal. If you're looking for some deeper information, like how is this exactly working, then you need that explanation part, the fundamentals pages. And if you just want to look up some method definition, you probably want to take a look at the API reference. And this solves problems, like the framework, the Diataxis framework solves problems related to documentation, and like what it does, like the action you want to solve, the style of how to write documentation, but also the information architecture, as you can see here. And like, for example, the action is like tutorials and how-to guides, and then you have the API reference for studying, for example. And they describe a very simple workflow, and the simple workflow is look at the documentation that you have, find something that you don't like, improve it, and repeat that as often as you can. And that's what I meant with, if there's a question being asked by someone, document it, because obviously something is missing there, and you want to improve that. And this is also what I said about API governance, because someone has to be responsible for that. It's not something that it's being asked, someone answers, and then it's forgotten on Slack or somewhere, but someone has to have that responsibility to follow up with it and make sure that it ends up in the documentation. And this is a screenshot of our guides. So you can see that our guides give some explanation on how to use the API, but they also have like code examples that you can just copy paste and kickstart your project. There's some shell code with gRP curl, which is basically curl for gRPC. that you can just copy paste and try out in the shell if you don't want to have a project set up. And I actually have the PR open for Scala examples, but I needed to focus on getting the slides ready. So I couldn't get that merged, but they'll be there next week. So just maybe just copy the link and open it next week. And then I promise there's also some Scala examples because the code is basically ready. And then we have the problem that you have this code and it's there on the documentation website, but how to keep it in sync with what's actually happening. And we did that in a way that we have a real test set up in our documentation GitHub repository. And that's on every change to protos or every change to the tests, they are executed against our integration environment. So this way we can actually ensure if the documentation is changed, that the documentation matches with whatever is deployed on integration. At best, integration has the same code than production. We also ensure that the examples given the documentation actually work, because we've all seen pages where you just copy some documentation and it's outdated, doesn't work. And it also helps for the teams that work on the server side to put themselves in the shoes of integrators writing the client. So it's a different perspective for the teams to use the service. And we just do that with GitHub Actions, for example. So we include the test file, the test code that we've written in the Markdown files, and we can just render that nicely for the website and ensure that our documentation keeps up to date. So that much about documentation. Now let's take a final look at gRPC streaming, because gRPC streaming is complicated. So far I talked mostly about unary RPCs, and let's have another look at your unary RPC. You have a client and a server here, and what usually happens is the client sends a request to the server, and it first sends the RPC method, so that's this order trip, for example, and some headers, for example, authentication. And then there's the message content, and what the server does, it replies with some headers, for example, status code, and the message content, like the response, and some status, like status code is in the trailers, and the headers, there's maybe some other tokens in there, continuation tokens, and we have this single pair of request and response. So it's very similar to REST, as we all know. With streaming, we have basically 4 different variants of RPCs. So like there's this unary call in line 1, that's what we just saw. And with streams, we have that stream keyword, and you can put that in different places. So client streaming call just puts it in front of the request, so that is a stream of requests incoming and just one response, something maybe for uploading large files. Then there's the server streaming call, maybe for downloading large file in chunks. You have one request, give me that file, and then we do chunks of, then stream chunks of the response. And then there's bidirectional streaming, which I wouldn't recommend to use at all because it's highly confusing to stream in both directions at the same time. And I still have to find a very good use case that I couldn't model in client or server-side streaming. But let's take a look at client streaming, for example, here. So again, first some method and headers, then multiple messages being sent, and what the server can reply is first headers, and then multiple messages in the end, their status and trailers. And we have long-lived connections, so they can stay open, and we have multiple messages being exchanged here. So this is actually bidirectional streaming. So. But there are issues with gRPC streaming. So we work with, as I said, with Go and Kotlin, and it kind of worked nicely. We're running everything on Kubernetes, our services, and have them behind an AWS application load balancer, so on AWS. And then we had errors in there, sending status codes, and somehow the status codes didn't work with the Scala libraries, no matter which we were using. We were highly confused, and it took us actually a long time and some weeks to figure it out and hard debugging what's wrong. Because the ALB has some specific behavior on how they interpret the gRPC spec. So it's according to the spec, and also libraries were according to the spec, but ALB is a bit strict, AWS is a bit stricter on that. So what happened with the Scala PB library for Zio, what happened with PECO HTTP is actually that the headers were sent immediately after processing the request, but before knowing the status code, because as I said, the status code should at best come in the trailers or with the trailers. So what needed to be fixed is to delay the sending of the status code and the errors until the first message is ready or we have an error. And that required fixes in the PECO library. We also later had that in the akka library and also in the ZIO library. So props to some of my colleagues who worked on that, because there was quite some effort to find that. So now you're basically ready to use gRPC streaming with Scala, but there are also some other limitations. Rate limiting is kind of hard if you have long-lived connections, because if you open a request and then just like stream responses, how to do rate limiting on that, because there's just one request. And if you want to rotate the token or revoke a token in between, then you basically have to kill that connection. That's not easy to manage that. So rate limiting streaming is not easy. Also, network configuration is a bit hard because connections can be dropped and lost, and you need to reconnect, and you have to basically do much of that on your own. You have very limited support by API gateways. So if you're on AWS, you kind of know the API gateway tool and you would want to use it, but it doesn't work with gRPC. On GCP, there is something that works, but also not with gRPC streaming. So as far as I know, there's only the type gateway out there, and then that's the one that we are using, but they also just changed to a business source license. We all know the story with akka. So it's not that easy as well. And gRPC streaming is really not like, you think it's, oh cool, it's nice, I can just now exchange messages. Feels like Kafka, but it's not Kafka. Because like you have to implement all of the things, like what happens if a client misses a message? Do I need to replay stuff? Do I need to keep track of this client has seen message X, this client has seen messages up to Y, and they want to get that. And connections do drop every once in a while, usually after 15 minutes, and then you want to reconnect. So there's some overhead in gRPC streaming, and unless you're absolutely invested in gRPC and you think it's absolutely necessary to have streams, like high frequent data exchange, like more than 1 hertz, like 1 message per second, then take a look at streaming, otherwise just not use it, would be my recommendation. We do actually use polling for most of the use cases because we have long-lived connections anyway, so we don't do the TLS handshaking stuff all the time, and then we can just poll every 4 or 5 seconds to get updates, which is totally sufficient in our use case because like vehicles do drive fast, but also not that fast in the city center that it's okay to have the vehicle position every 2 or 4 seconds, at least for showing that to customers in the UI. It's a different case if you're talking about controlling the fleet and making sure that vehicles doing nothing stupid. All right, to summarize a bit, REST is de facto the standard. So if you're like getting into gRPC, you have kind of steep learning curve. I wouldn't say steep, but you have a learning curve that you need to take into consideration. As I said, gRPC streaming is very complicated, and few API gateways do support it, so be cautious about that. You have a bit more complicated network configuration also, because like standard load balancers don't work with that easy. gRPC does not work with serverless, so we have everything running on Kubernetes, not a problem for us, but if you're heavily invested in, I don't know, AWS Lambda and want to use that, maybe gRPC isn't right for you. And I think API governance is key, so making sure that you really build the best API and having an oversight over the whole process. And as I said, not so much Scala code, but if you have questions about how we actually implemented more of that in Scala, then the short examples that I've shown, come talk to me, ask questions now. There are also some of my colleagues here who actually worked on the Scala implementations, unlike me, so they can answer in more depth. Feel free to reach out, and yeah, we're also hiring. Thank you.
We have about 5 minutes for the Q&A sessions. Who wants to ask questions?
Hey, thank you so much. This was amazing. You mentioned some limitations in the gRPC streaming when applying to the sort of Scala-generated code, for example. But did you see anything in the sort of the core protobuf Scala PB stuff? Because like I work with protobuf from Go, and like lack of proper code products like seal traits and all of that, and modeling that has been a bit of an issue. So I don't know how Scala PB encodes that, but like, did you ever face a situation where we want to encode this like this in a Scala code, but we have to use protobuf and it doesn't support it, so you kind of reduce the safety of the modeling?
No, actually, Scala PB is an awesome library. Really have to compliment the author. We did do some PRs here and there, but mostly everything in Scala PB worked like a charm. And you have, like, as I said, there's optionality in protobuf, and then you can even like have an optional keyword, then it wraps everything in an option in Scala. It has all the built bindings for like all the different libraries, ecosystems that you want in Scala. So I think we didn't face any issues there. The issues were really with the HTTP libraries, so like Zio HTTP, Akka HTTP, Paco HTTP, that we needed to change a bit. Maybe, did you remember anything where Scala PB didn't work? No, it was really perfect. Like, it's actually interesting that Nadev doesn't talk about that more, because it's crazy effort that he puts in there.
We still have time for other questions.
Hello, thanks for the talk. With regards to streaming, you would probably have the same issues if you use server-sent events as well, because that also is a long-lived connection, and all the different problems would occur there as well.
Yeah. We kind of hoped that we could use gRPC as a one-stop solution to solve the like event-based communication kind of thing, because what you don't want to do, or we didn't want to do, is give public transport operators access to our event bridge, SQS, Kinesis, whatever queues, streams, because that feels wrong to have them access our AWS or Kafka, whatever you want to use. And we hope not to need webhooks or something, because webhooks also have their limitations. But in the end, streaming was just too complicated also for them to use. We do use it internally a bit, where we think we have it under control, and have spent much time on the learning curve, but we have yet to have some outside integrator. So what we do with all of these APIs is we kind of like dog food them by using them for our own apps as well and our own services, to really make sure that we also get the integration perspective internally. So we have teams that consume these APIs, and we have teams that build these APIs, and they also, at best, only talk over documentation with each other. So streaming is, we have it working and it works, but be cautious.
Hi, I think we had time.
Thanks a lot for the talk. You mentioned a lot of advantages for gRPC.
Mm-hmm.
Have you also seen enhancement in terms of performance, especially response time and used bandwidth, from going from a text format to a binary format?
We were using protobuf over HTTP 1.1 before, so we didn't have that serialization up advantage, right? Because we were already doing the serialization. So for us, it was mostly that modeling part and using the ubiquitous language also for the method names and the RPCs. What we did see was like that the long-lived connections and like having like the handshaking only ones that helped a bit and make that a bit more performant, but it's not that we say this is a huge game changer for us. I think coming from like JSON over HTTP1, then you would see that advantage and that would probably pay off. But I think the bigger argument for protobuf is actually that you have this nice data format that you can share, and it's much better typed than whatever you want to do with OpenAPI and JSON or GraphQL. And I think this is superior. Like, especially if you have a strongly typed language like Scala, if you're using TypeScript, whatever.
Thank you. Is there any quick questions? We can still have 2 minutes. Otherwise, thanks for the talk.
Sure.